Okay, to actually find the perimeter of this sector, of this segment, sorry. The segment is this shaded spot here. First of all, what you need is you need to go around the outside. So you need that spot there, which is theta on 360 times 2 pi r, because it's a fraction of the circumference. Now, pi on 3 is 180 on 3, which is 60. So it's going to be 60 on 360 times 2 times pi times 5. So that would be 1 on 6 times 10 pi. So it's going to be 10 over 1. So 10 pi times 1 is 10 pi. 6 times 1 is 6. So it's 5 pi on 3. That's what that length there is. Then all you need to do is get this length along here. Now to get that, we have this triangle here. That's 60, that's 5, that's 5. So if you use the cosine rule, you might also, I'm just going to use the cosine rule just in case you can't do this, but if you look at this, it's actually an equilateral triangle. Because if that's 60, these two add up to 120, and 120 divided by 2 is 60. So it means that if that's 5, that's 5. This would also be 5. But if it wasn't 60, then you're unable to do that. So you'd need to use the cosine rule. So it's 5 squared plus 5 squared minus 2 times 5 times 5 times cos 60. And when you work that out, you get 25. The square root of 25 is 5. So now when you go to get the whole perimeter, you have this 5 here, plus the 5 pi on 3. And all that is required now is you just get the whole perimeter, so you add them together. 5 pi on 3 plus 5, and the units are centimetres. And that would be the perimeter of that segment. If you wanted the area of that segment, that would be, you have to do the area of the sector, and then you'd minus the area of the triangle. So to get the area, and get the area of the sector, which is theta on 360 times pi times radius squared, that's 60 on 360 times pi times 5 squared. Okay, so then that cancels down to 1 on 6 times pi, 1 times 25, which is 25 pi on 6. So that's the area. That's the area of the whole sector, so all of this. And then what you need to do, okay, so it's 25 pi on 6. Now what you need to do is get the area, the area of the sector part, of the triangle part, sorry. So it's a half AB sine C. So it's a half times 5 times 5 times sine 60. Okay, so that's going to be 5 on 1, 5 on 1. So it's going to be 25 on 2. Now, sine 60. If you go to your formula sheet, you'll see this triangle be 60, 30, and 2. And if you're looking at sine 60 is opposite on hypotenuse. So if I'm going to get it in exact form, that would be root 3 on 2. So it's 25 root 3 on 2. So the total area would be 25 pi on 6 minus 25 root 3 on 2. And that would be centimetres squared for that. Okay. You could get the sine 60. You could get the sine 60 and put in your calculator. You'll get like a long decimal because it's a third. Then when you square it, so you press the x squared button, you end up with 0.75. If you change that to a fraction, it would be 3/4. And now just square root it yourself without the calculator. And you can see it will be root 3 on 2. That's another way of getting like the sine 60 part in exact form.